गुड मॉर्निंग बच्चों। प्रीवियस सेशन में हमने फर्स्ट ऑर्डर रिएक्शन काइनेटिक्स के थ्योरेटिकल एस्पेक्ट्स कवर किए थे। आज हम कुछ न्यूमेरिकल्स लेंगे जो बोर्ड लेवल के होंगे और पास्ट ईयर एग्जाम्स में आए हुए हैं। और नेक्स्ट सेशन जो होगी उसमें हम ज्वाइंट एंट्रेंस एग्जाम के पास्ट ईयर क्वेश्चंस लेंगे। तो इसमें हमारा जो फार्मूला मेनली यूज होगा दैट इज टाइम रिक्वायर्ड फॉर द कंसंट्रेशन टू रिड्यूस फ्रॉम इनिशियल कंसंट्रेशन ए नोट to the remaining concentration A is given by this formula where K is the rate constant. Okay, so first numerical is the rate constant for a first order reaction is 60 second inverse. That means we are given the value of K equal to 60 second inverse. How much time will it take? So we are required to find the time to reduce the initial concentration of reactant to its 1/10th value. Suppose the initial concentration is A naught and this will reduce to A naught by 10. So इसके लिए हमें टाइम निकालना है कि कितना टाइम चाहिए उसकी कंसंट्रेशन को 1/10 होने के लिए। तो इस फार्मूले में हम रख देंगे टाइम रिक्वायर्ड इज 2.303 अपॉन K log ऑफ K की जगह हम रख देंगे 60 बिकॉज K इज गिवन एज 60 सेकेंड इनवर्स log of A naught upon A is A naught by 10 because concentration becomes 1/10th. So this will be 2.303 upon 60 into log of it will become 10 and log 10 is 1. So this will be 2.3 roughly we can say 2.3 divided by 60 this much seconds. So that will be the answer you can find out. Okay, so now we take the second numerical. We say that the first order reaction takes 100 minutes. A first order reaction takes 100 minutes for 60% completion. For 60% completion. Find the time required. Find the time required for 90% completion. So this type of numericals are asked many times. So how you will solve this type of questions? So we will write the given data. The time is 100 minutes. Okay, for 60% completion. What do you mean by 60% completion? Suppose the initial concentration A naught was 100 moles per liter. So 60% completion means the remaining concentration A will be 40 moles per liter. Okay, so now we put in this formula, we will get 100 is equal to 2.303 upon K log of A naught by A means 100 by 40. So this is equation number 1. Now we have to find the time required for 90% completion. Let the time be T for 90% completion. So in this case our A naught will be 100 and what is the remaining concentration after 90% completion? It will be 10 moles per liter will be remaining because it is 90% complete. So remaining concentration will be 10. So we put in this formula again. So we will get 2.303 upon K log of, in this case it will be 100 by 10. Okay, 100 by 10. So we have got the two equations. Now, so these are the two equations we have made. Equation number 2 and this log 10 is 1, so we divide equation number 2 by equation 1. So 2 divided by 1 will give time required for 90% completion divided by 100 is equal to, this term will cancel out. Okay, so we will get log of 10, 100 by 10 means log 10, and this, it is nothing but 1. Okay, divided by, this will be log of 100 by 4 means 10, 100 by 40 means 10 by 4. Okay, so log 10 is 1, and this will be log 10 minus log 4, so it will be 1 minus log 4, and log 4 is nothing but 2 log 2, so 2 into 0.301, so this is the value of t by 100, so you can find the value of t, that will be in minutes, unit will be minutes. You can find easily the value of time required for 90% completion. Okay, so now we take 2 more numericals, then we will wind up this session. Now the third numerical is following data are obtained for a reaction, that is a reaction given N2O5 gives 2NO2 प्लस हाफ O2, और इसके लिए कुछ एक्सपेरिमेंटल डाटा हमें दिए हुए हैं, वेयर टाइम इज इन सेकेंड्स and concentration of N2O5 is given as moles per liter. Okay, this is say at different times these data are given to us. So at t equal to 0, then t equal to 300 seconds, then t equal to 600 seconds, and this is 1.6 into 10 to the power minus 2, and this is 0.8 into 10 to the power minus 2, and this is 0.4 into 10 to the power minus 2. ये 3 डाटा हमें दिए हुए हैं, and we have to show that it follows first order reaction. We have to show that it follows first order kinetics. Okay, and second we have to find the half life. Okay, so how we will do in such type of numericals where we are given different data for the reaction, we will find the value of k in each case. Okay, suppose I use these 2 data, okay, one this and one this, and I find the value of k. Then similarly I use this and this, and again find the value of k. If both the values of k are found to be same, then we will say that it is a first order reaction. So we apply this formula of first order, where k is given by 2.303 upon t. From this formula we can rewrite as k equal to 2.303 upon t log of a naught upon a. तो पहले हम फर्स्ट ये 2 डाटा के लिए अप्लाई करेंगे, दिस एंड दिस. ओके, देन वी नो दैट इट इज हाउ मच टाइम टेकन, 300 seconds. So time is 300 seconds. Okay, in which the concentration gets reduced from this to this. So a naught we can write as 1 log of 1.6 into 10 to the power minus 2 upon, this is the remaining concentration after 300 seconds. So I will write 0.8 into 10 to the power minus 2. So we need not solve this, we will just write as it is. So it is 2.303 upon 300 log of 2. Okay, now this is the value we have found out from this one data, that is these 2 data. Now we will use this and this, first and third data. Okay, so again we will find the value of k, that will be 2.303 upon time. Now the time is 600 seconds. Okay, from here to here it is 600 seconds into log of this 1.6, that is initial concentration will remain same, divided by remaining concentration after 600 seconds. It is 0.4 into 10 to the power minus 2. So this will be 2.303 divided by 600 into log of, this will be 4. Okay. So we can write this as 2 log 2. So this will be 2.303 upon 600 into 2 log 2. Now you can see both these are same. So this k value and this k value both are, because this will cancel out. So it will be 2.303 upon 300 into log 2. As both the values of k are found to be same, that means this reaction follows first order. Okay. Now half-life we can easily calculate. We know that half-life for first order reaction is log 2 by, that is 2.303 log 2 by k, or we can write 0.693 by k. Okay. Now k we can find from here. So k will be 2.303 upon 300 into 0.301. So we know the value of k, we put here and we can find the value of half-life. So that is how we can solve such type of problems. Now I take one last numerical, and which is very important for understanding point of view. Okay, and this is related to the gaseous reaction. Okay, so we are given that the following data were obtained. The following data were obtained during first order thermal decomposition of SO2 Cl2 gas gives, this is a reversible reaction which gives SO2 gas plus Cl2 gas. Okay, so this is the reaction, and the experiment was done. The two experiments were done, that is experiment number 1 and experiment number 2, and here it is tabulated. This is the time in seconds, and this is the total pressure. Okay, so this is the total pressure, and the unit of pressure is atmosphere. So these two experiments were done. Here I will write experiment 1. This is experiment 1 and experiment 2. Okay, like this. So when time was 0 second, the total pressure was 0.4 atmosphere, and when the time was 100 seconds, the total pressure was 0.7 atmosphere. And what we have to find out is the find rate constant. So we have to find the value of k. Okay, so how we will do about, because this is a gaseous reaction, so I will write here SO2 Cl2 gas gives SO2 gas plus Cl2 gas. Okay, now let us assume that the initial, because this total pressure was 0.4 initially, okay, and initially only reactant was present, there was no products, so we can say that initial total pressure is same as the pressure of reactant. यानी जो 0.4 जो प्रेशर है at time t equal to 0, ये क्या है, ये टोटल प्रेशर है, but because only reactant is present initially at t equal to 0, there is no product formed, so we can say that this is the partial pressure of SO2 Cl2 is same as the total pressure, because initially SO2 and Cl2 were 0. Okay, so whatever the total pressure is there, that is for the reactant only. Now when t is equal to 0.7 seconds, when t is equal to 100 seconds, okay, then our total pressure is 0.7 atmosphere. So how we will do? Suppose in time t equal to 100, this gets decomposed and remaining concentration is 0.4 minus x. After t equal to 100 seconds, suppose x moles of SO2Cl2 gets dissociated. So remaining will be 0.4 minus x, and x of this will be formed and x of Cl2 will be formed. So what will be the total pressure at t equal to 100? Total pressure will be, what will be the total? That is 0.4 minus x plus x plus x. So this is the total pressure. So it will be, x will be cancelled out. So this will be 0.4 plus x. Is it clear? Because this is the total number of moles, we can say, or this is the partial pressure of SO2Cl2, because after 100 seconds x moles are dissociated and x of SO2 will be formed and x of Cl2 will be formed. Because for each 1 mole of SO2Cl2 dissociated, we are getting 1 mole of SO2 and 1 mole of Cl2. So this is the total pressure after 100 seconds. Okay. Now we have to apply this formula. For that we need to know what is the initial pressure. Initial pressure was 0.4 for SO2Cl2, because now we will see that initial pressure of SO2Cl2 was 0.4 एटमॉस्फेयर. अभी हमें देखना है कि SO2Cl2 का फाइनल प्रेशर कितना है. ओके, नाउ वी आर गिवन दैट टोटल प्रेशर आफ्टर 100 seconds is 0.7. So this we can equate to 0.7. Total pressure is 0.7 and this is 0.4 plus x. So we can say that 0.4 plus x equal to 0.7. So x will be 0.7 minus 0.4, that is 0.3. Okay, now we know the value of x. So what will be the this partial pressure of SO2Cl2 after 100 seconds? That will be 0.4 minus x. So this pressure of, there is no need to write square bracket because we are writing the pressure. So P naught is 0.4 atmosphere, and what will be the partial pressure of SO2Cl2 after 100 seconds? That will be 0.4 minus x, that is P will be 0.4 minus x, and x is 0.3, so 0.4 minus 0.3, that is 0.1 atmosphere. Okay, I hope this is clear to you. First we have found out the total pressure, okay, after 100 seconds, because x moles gets dissociated or x partial pressure gets reduced. So this is the total pressure. अब टोटल प्रेशर हमें 0.7 एटमॉस्फेयर दिया है आफ्टर 100 सेकंड्स, तो हमने इसको 0.7 से इक्वेट कर दिया और x की वैल्यू निकाल ली. अब हमारा 100 सेकंड्स के बाद SO2Cl2 का जो प्रेशर है दैट इज 0.4 माइनस x. सो 0.4 माइनस 0.3 दैट इज इक्वल टू 0.1. अभी हम जो है इस फार्मूले में लगा देंगे. अभी हम इस फार्मूले में लगाएंगे तो ये क्या बन जाएगा हमारा, लॉग ऑफ दिस विल बिकम P naught upon final pressure, that is P. Okay, so इसमें हम रखेंगे तो we will get 0.4 upon 0.1. यहाँ पे आएगा 0.4 और यहाँ पे आ जाएगा 0.1. So this is the formula. Now we are given the, we have to find the value of K. So time हो जाएगा हमारा 100 seconds. ओके, t की जगह 100 सेकेंड्स हो गया एंड वी कैन फाइंड द वैल्यू ऑफ k. ओके, सो आफ्टर 100 सेकेंड्स दिस इज द प्रेशर ऑफ SO2Cl2 and the initial pressure was 0.4. So that is how you can solve this type of numericals. I hope this concept is clear to you. Now in the next session we will take the numericals which were asked in the past year joint entrance exam. Okay, and I wish you all the best. Thank you.